Okay. See here, why I am taking voltage across the inductor as 50? At T is equal to 0, I am taking VL is equal to 50 volts. Okay, listen here. At T is equal to 0, inductor is open circuit. In open circuit, what is the voltage? Voltage will be present. Current is 0. In open circuit, your current is 0. But voltage is in this loop only 50 volts. In the entire loop, the voltage is only 50 volts. That's why I am taking 50 volts in the voltage across the inductor. Then tell me what is the value of di by dt?
5.
5. Note down this. Note down this. Now substitute I is equal in the equation 2. Substitute I is equal to 0, t is equal to 0. In this equation, substitute I is equal to 0, c1 into e power 0 plus c2 into e power 0. T is equal to 0. In place of t, 0 is substituted. Therefore, c1 plus c2 is equal to 0. Let it be equation 3. c1 plus c2 is equal to 0. Let it be equation 3. Now see. Now for equation 2, I am taking di by dt. Because I know di by dt, for equation 2, I am taking di by dt. That is c1 into e power minus I am taking the derivative of equation 2. Taking the derivative of equation 2. Now we know di by dt value. Substitute di by dt there and t is equal to 0. Substitute t is equal to 0 and di by dt is equal to 5. Substitute di by dt is equal to 5. c1 into e power 0 t is equal to 0 and di by dt is equal to 5 is substitute. We will get this is equation 4. Now we can solve equation 3 and 4 for getting C1 and C2. Now we are having two equations, 3 and 4. If you solve 3 and 4, we will get C1 and C2. We will get C1 and C2. See here, I am solving these two equations. So I am solving C1 and C2. See how to solve C1 and C2. First I am writing down C2 coefficient. So in equation 3, what is C2 coefficient? C2 coefficient is 1.
298.
Okay, 1 in the equation 4 minus 298.32. These two are C2 coefficients. These are constants. C0 and minus 5. Constants are 0 and minus 5. Next is C1 coefficients. These are C1. See here. This is C2 coefficient. These are constant coefficients. C1 coefficients. C2 coefficients. We had to write first C2 coefficients, then constant coefficients from equation 3 and 4. From equation 3 and 4. Then C1 coefficients, then C2 coefficients. Then we'll solve C1 and C2. Cross multiply this. That is
Minus 5.
minus 5 plus 0, 0 plus 5. That is minus 298.32 plus 1.676. Now C1 is now your C1 is cross multiplied with a constant term. Minus 5 by what is this value? Minus 298 point something divided by
Minus 296.6.
minus 296.644. This is the value of C1. Now tell C2 is cross multiply this. 5 by minus 296.644. What is this value and this value?
0.0167.
These are the values of C1 and C2. In this way, we will solve C1 and C2. Now substitute C1 and C2 in equation 2. Substitute C1 and C2 in equation 2. What is this equation? E power minus 1.67. Your C2 is this is your current transient equation. We have determined the constant C1 and C2 and we have substituted in equation 2. Substituted in equation 2. So we got the current equation, current transient equation for RLC circuit. Now read the problem. What else he is asking?
Maximum value of the current.
Maximum current also he is asking. We have determined the current transient equation and he wants maximum current also. So if you want to get the maximum current in mathematics, what you will do?
Different.
We will take the first derivative. After that,
Equals to 0.
we will equate it to 0. We will take first derivative of this current and we will equate it to 0. That means we will take di by dt. For this current. For this current, I will take di by dt and I will make di by dt is equal to 0. Then I will get one condition. After getting that condition, if you substitute that condition in this equation, we will get maximum current. So now take di by dt for this equation. So I have taken the derivative of that equation. Write down this. Now make dA, in the next step, make dI by dt is equal to 0. In the next step, equate this dI by dt is equal to 0. In the next step, write down, take dI by dt is equal to 0 for getting maximum current. Take dI by dt is equal to 0. Take dI by dt is equal to 0 to get maximum current. Otherwise, to get maximum condition. Take dI by dt is equal to 0 to get maximum condition. To get maximum condition. Now we do one thing. Have you taken dI by dt 0? Okay. Now we bring this term to this side. If you bring this term to this side, it becomes plus. If you bring this term to this side, it becomes plus. Bring one term to that side, it becomes plus. Now you can cancel this. The negative term, bring it to the other side. Negative term, bring it to the other side. Then these two will be cancelled. Now what I am doing is, see here, this negative and negative also cancel. 1.7 e power minus 1.6765. Bring this to this side. E power minus 298.32 into c is equal to 298.32 by 1.67. Bring the e terms on one side. Bring e power terms on one side. Constant terms on the other side. This becomes if you bring it to the numerator, it becomes plus. Minus 298 will become plus. What is this value? 298 minus 1.676, how much? How much you will get? E power 296 point. See here, I am taking ln. I am not taking log. Why I am taking ln? Why not log?
Base E.
Because ln base is e. For log, the base is 10. So if you want to remove the base e, then you have to take base e also. In your calculator also, don't take log. You have to take ln in your calculator. Now tell me what is the time?
Sir, 177.9, sir. 298 divided by
Okay,
1.6.
177.9. Okay. That means 178. I can take it as 178
Yes, sir.
approximately. We'll get 0.017.
Yes, sir.
This is the time. So we have got, now this is the, if you substitute this time in current equation. What is the equation for the current we have written? Equation 5 it is?
Yes, sir.
Okay. In equation 5, substitute this t, we will get maximum current. Substitute this t value 0.017 in your current equation, you will get maximum current. Substitute this t value in equation 5. In place of t, substitute this value. We will get maximum current. If you substitute t value, we will get this current. Substitute and check. Meanwhile, I will take the results. If you substitute this t value in equation 5, we will get maximum current. So this is the maximum. Your condition is t is equal to 0.01 second, maximum condition. If you substitute this t in that current equation, you get maximum current.